We have a question here on moment of a force and equilibrium forces. Moment is the product of force and the perpendicular distance. And for a body to be in a state of equilibrium, there are conditions for equilibrium. One, with respect to forces, the total forces in one direction must be equal to the total forces in the opposite direction. So, the forces acting upward must balance with the forces acting downward for the body to be in equilibrium. Two, with respect to the moment about a point, if we consider a turning point, the algebraic sum of the moment about a point must be equal to 0 if a body will be in equilibrium. And in other words, the total clockwise moment must be equal to the total anticlockwise moment. In this question, a uniform meter rule AB balance on knife edge 60 from end B. If we consider this as point A and this is point B, and this is a meter rule, when we say a meter rule, the total length should be 1 meter. So, and that is 100 centimeters. And we are told that this meter rule is balanced at 60 from the end B. If from here to here is 60, so from here to here you'll be 40. So the balance is at position on 40 centimeters. This is the balance, the knife edge. What is the weight? That is, when a load of 22 is kept 10 centimeters from end A, from here to here we have 10. At this position 10, a load of 22 is hung on this rod. We are to find the weight of the meter rule. Generally, the center of gravity or center of mass for a uniform body is at the middle. Now, if this rod AB is uniform, the weight should be acting at the center. That is at the 50 centimeter mark. So this is 50 cm. That is where the weight should be acting. And when calculating moment, we must know that if the turning point is at the pivot, the total distance from this mass to the turning point from here to here, if this is 40 and this is 10, the difference will be 30. So this is 30. And if this is 50 point and this is 60, the difference from the turning point to this will be what? 10. Now, by the principle of moment, the weights will be turning the meter rule clockwise. This is a clockwise moment, turning it in a clockwise direction. Then the mass will be turning it in an anti-clockwise direction. That is anti-clockwise. This is anti-clockwise. The principle of moment says the total clockwise moment must balance with the total anti-clockwise moment. So in the clockwise direction, we have 10. That is W times 10. So we have W times 10 must be equal to the anti-clockwise. We have 22 times the distance, which is what? 30. That is 22 times 30. And now we have our weight, W as 22 times 30 all over 10. This cancels out. We have our weight as what? 66 what? Grams. That is the answer. That is option C.